Last lecture we have learned one thing which was Lagrange's 0-1 block. That was one. Second thing which we have just defined and proved a couple of theorems related to arithmetic progression. So first term is A, second term is A plus D, third term is A plus 2D, etc. My percentage is very low or very high. A plus D, A plus 2D, A plus 3D, dot 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 dot, A plus n minus 1 times D. Okay. And we solved a couple of problems also. Now the question is, if I want to add them, summation of all these numbers which are in arithmetic progression, we want to find out. So find out summation of n numbers which are in arithmetic progression. Okay, so the technique is reverse and add. You reverse these numbers which are in arithmetic progression and add them. So because we are reversing the direction, the summation is not going to change, therefore S will remain S. The last term will come below first term, second last term will come below second term, and if we look at these shapes that I have created, the summation of those two numbers is 2a plus n minus 1 times d. Always. See here, a plus a, 2a. N minus 2d plus d, n minus 1d. See, 2a, n. So all of them add up to this. And how many of them are there? N. But then when we add LHS, we get 2s. Therefore, S is equal to n by 2, 2a plus n minus 1 times. So this is the formula for summation of n terms of an arithmetic progression. Summation of n terms in an AP with first term equal to A and common difference is equal to D. This need to be remembered. And the technique, this technique is used for the first time, reverse and add, in this place. But this is a problem solving technique. Many times you will realize that just by reversing and adding, you can solve the problem. And this technique will be required to be used in future, and therefore this summation is important to us.
Excuse me, sir.
Yes.
Sir, what I did was I said that there will be NA.
Question 1. If T21 is equal to 100, find S41. S41 is summation of first 41 terms of AP. Of course, while writing this question, I should write that Tn is an AP. Otherwise, it doesn't make any sense. Tn is an AP. Term number 21 is 100. Find the summation of first 41 terms. Let us look at that formula. S is equal to n by 2 into 2a plus n minus 1 times d. Can I write it like this? N into a plus n minus 1 times d upon 2. I can write it because this is 2a. N minus 1 times d, 2 goes outside and minus, same. No difference. But then there is a difference. This is an inside bracket first term plus last term upon 2. Oh, very good. Now, arithmetic progression looks like points equidistant. Now I have put 11 points. Okay. So distance between these 2 points, same. These 2 points, same. Okay. Now these sitting by distance same, that means the common difference is same. Okay. So maybe instead of writing a plus d etc., let me write down some numbers. 2, 5, 8, 11, 14, 17, 20, 23, 6, 29, 32. They are keeping exactly same distance between them. So always arithmetic progression can be geometrically visualized as points sitting on the real number line at exactly same interval. Okay, now suppose this is a rod and we want to balance it. Or no, not balancing. So if I reverse and add technique told us that you look at first and last term together. Okay. So if I add first and last term, what do I get? 34. Very good. Then this is like seesaw. I mean, seesaw is at the center, there is a pivot, and this way, that way. So if you take 5, then you have to take 29. They add up to 34. 8 and 26 add up to 34, and so on. 34, that is what is our reverse and add technique. You are adding all of them by reversing the order and saying that they are 34. And there is only one remaining. So maybe you can add to itself and make it 34 or keep it like that. Okay, because when we are adding all of them, adding it unnecessarily will give us wrong answer. And therefore, how many such pairs are there in this case? There are total 11 numbers. And we got how many pairs? 5 pairs. 5 pairs adding equal to 34. And one number remaining, 11th number, because they are pairs. So if it is odd, then always one number will remain, which is the number at the center, and it is 70. So total will be 5 into 34 upon 7. So practically it is 5.5 times 34. Hey, do you understand? Total summation is how much? 5.5 times 34. 5 times 34 and 1 time 17 is 5.5 times 34. But 5.5 is 11 by 2. So total numbers were 11. Out of divided by 2 is 5.5. There will be 5.5 pairs, and each pair will be 34. So, but then can you really every time you will have to look at this, or it is okay if you add first term to the last term, you get the sum, and first term plus last term upon 2 is average. So sum of all the numbers in an arithmetic progression is average of those numbers into total number. In a class, students get different marks. I want to find out average. I add all the numbers that the students have got. That gives me S, and I divide S by N to get average of my class. Now it is I want sum, therefore I know average, I multiply by total number. Now if T21 is given, 21st term is a middle term of 41 terms in an arithmetic progression. That is the only critical thing that need to be noticed. Before 21st term, there will be 20 terms. Then T21 will be there in between. And after that, how many terms? 20 terms. So this balance is ready now. Okay. It is okay. If you know first and last term, fair enough, you do this calculation and get the summation. But if you do not know first and last term, but you know only middle term, which is given to be 100, then middle term is first term plus last term by 2. That information is available to us. So this is 100, total number of terms 41, average is 100, therefore answer is 4100 for this problem. I mean, it is easy problem, but I need to give proper explanation. Next one. Any doubt, any difficulty to any student? Consider an AP. नहीं. Consider an AP Tn. N belongs to natural number. Find real numbers U and V such that UT3 plus VT7 is equal to S100. बघा जगतंय का? Shall I explain? U is a real number which you are supposed to find out. V is a real number which you are supposed to find out. T3 is term number 3 of the given arithmetic. T7 is term number 7 of the given arithmetic progression. And in RHS you have first 100 numbers. Find U and V.
Sir, mine.
Correct. V, whoever is showing. Now let me show because I was not ready with the answer. Let me directly solve it. Now we have to use basic formula. T3 is equal to U into A plus 2D. That is T3 plus V into A plus 6D is equal to 100 by 2 into 2A plus 99D. Good. And therefore U plus V times A plus 2U plus 6V times D is equal to 100 times A plus 99 into 50 times. We have to compare coefficients here to arrive at value of U and V. Multiplier of A must be 100, implies U plus V is equal to 100. And 2U plus 6V is equal to, someday or the other I have to multiply this, therefore 0. 9 × 45 से 5, 8 से 4, 9 × 45 से 4, 49. Okay, so I can simplify this. U plus 3V is equal to 2 बेचौक 8 बेसत्ती 14 बेपंचे 10. Okay, so now if I subtract equation 1 from equation 2, I get 2V is equal to 2475 minus 100 is equal to 2375. Therefore V is equal to 2375 upon 2. And therefore, U is equal to 100 minus 2375 upon 2, which is equal to 2175 with negative sign upon 2. That is what is your answer.
I did not
Why is u
understand.
plus v equal to 100?
It is given, na? Coefficient of A is 100, coefficient of D is 55. So we have to compare. We cannot mix them. We have to keep them separately. Then and then only this statement will work.
Yes, sir, but why is u plus v equal to 100?
Comparing coefficient, LHS should be equal to RHS. What is the coefficient of A here? 100. Can this expression produce A? No. Who can produce A? Only this expression. This expression. First term can produce A. Second term cannot produce A. Therefore, whatever coefficient of A is there in RHS should be the value of U plus V.
Sir, but why can't 2u plus, like, why does 100 have to be equal? Like, for example, like, d can be slightly bigger and a can be the coefficient of d here compared to coefficient of d and the RHS and the LHS. They can be a mismatch and they can still be equal, right? Or no?
How can they be mismatched? This is arithmetic progression. The moment I say Tn is arithmetic progression, A is first term and D is common difference. That is fixed. We cannot change that. So A in LHS has got exactly same value that of A in RHS. D in LHS has got exactly same value that of in RHS. Therefore, if I want to create RHS, for whatever A and whatever D you fix, corresponding U plus V must be 100. Corresponding to U plus 6 V must be 99 into 50.
Sir, but how can we tell that the corresponding first term of the LHS will be equal to the corresponding first term of the RHS?
Because you want 100 A's in RHS.
Yes, sir.
Who in LHS can produce A's?
Sir, but we don't know that if D can be 2 times of A then, and 2U plus 6U can be 50.
Huh?
So he's saying that, like, suppose 2u plus 6u is just.
Okay, so there is little ambiguity about whether there will be unique solutions V and U or not, which I think requires some additional thinking, which we will do and complete it eventually. Start. Next problem, U, V, W belong to R, consider a sequence Tn. Let Sn is equal to U plus Vn plus Wn square. Find the condition, necessary and sufficient condition, such that Tn is an AP. Compute first term and common difference. Now, Sn minus 1. Sum of n terms of an arithmetic progression minus sum of n minus terms in an arithmetic progression will be what? That is what is term number n. When you add term number n to Sn minus 1, you get Sn. Correct?
Yes, sir.
Number 1, as per our formula, is U plus Vn plus Wn square minus U plus V into n minus 1 plus W into n minus 1 bracket square. That is what is your Tn, which is U gone, Vn gone, what remains is V, Wn square gone. What remains is minus 2 Wn plus W, that is term number n, is equal to V plus W. अरे बरोबर चाललंय काय?
Yes.
So we minus W.
Minus W.
Yes, sir. Minus.
Oh, I'm lost somewhere.
Sir, I guess in the first equation would
First,
be, sir, minus V.
minus V into n minus 1.
Yes, sir, and minus W into n minus 1 the whole square.
I'm thinking about something else. Minus, minus. That makes it u gone, vn gone. So what is remaining here is v, correct? Then vn square is gone. What is remaining is plus, right? I am still in the earlier problem. I keep on thinking, u plus vn plus wn square minus u minus vn plus v minus wn square plus 2wn minus w. u gone, vn gone. And what is remaining now? It's equal to wn square gone. Is that right? So now what is remaining is v minus w plus 2wn. Is it correct now?
Yes, sir.
yes, sir.
Okay. And therefore, if this is term number, then this is a plus n minus 1 times d. अरे यार